out of 4 submerged surface, we completed the vertical plane surface, horizontal plane surface, inclined plane surface. Now our next topic, that is the curved surface. So when this is the curved surface here, so hydrostatic force on curved surface can be defined by two methods. So there are two methods. One is analytical method and second one is a graphical method, or it is also known as pressure diagram method. So let's understand the pressure diagram method. So the representation of intensity of pressure in the direction of force is known as pressure diagram. The volume of the pressure diagram is the total hydrostatic force and its centroid is the center of pressure. Let's understand this. So this is my handwritten notes. You can download it from the description. Like, share, subscribe my YouTube channel. So let's understand this question, this concept. So here consider this is one plate. So this is the plate and the height of the plate, that is h. Okay, so this is the plate here. So as you go downward direction, the pressure is increases. Okay, so this is the pressure and here the pressure is the maximum and that will be rho into g into h. Okay, now so g is the center of gravity and from g to the free surface, so here there is a free surface, so x bar that is equal to h by 2, and from center of pressure to the free surface, that is known as h bar. So h bar that is equal to 2h by 3. So h is the height of the plate. Now this is the free surface here. Now g is the centroid or center of gravity, cp that is center of pressure, v is the width of the plate. So consider the width of the plate, that is b. Okay, now so if you want to calculate the area, what is the area of this section? So that will be half into base into height. So half into base, so here to here the distance will be, that will be the pressure, that is rho into g into h, and what is the height, that is h. So if you want to calculate the area, that will be half into rho gh into height. Okay, now pressure diagram method says that just perpendicular to this plate, if the breadth is b, so just inside the paper up till this, if you want to calculate the volume, this volume will be the volume of pressure diagram. So this will be the pressure force. So if you want to calculate the volume of this surface, so you have to multiply this area into the breadth or width of the plate. So if you want to calculate the volume of pressure diagram, that is equal to half into rho gh into h, that is the total area of this is the area, and you have to multiply it by b to get it volume. Now rho g into h by 2 into h into b. So from here Fp, that is the pressure force, rho g we know that is equal to omega, and h by 2 that is here, that is h by 2, that is x bar. So x bar into area of plate, so h into b, that is the area of the plate. So this is very important. So here Fp that is equal to omega x bar into area of plate. Okay, so this is very important. Now for consider this is one plate and there is a free surface here, there is a free surface, and this is the center of gravity, and from the free surface to the center of gravity, that is known as x bar. So now if you want to calculate the Pg, that is equal to rho g into x bar, and if you want to calculate the pressure force, that is Pg into area. So Pg, that is rho g x bar into area. So this is the same formula, that is rho g x bar into area of the plate. Now one case, just understand this concept. So this is one vertical plate are there, this is some height, and from the below position to up till some depth there is a water, and after that there is a oil is there. Okay, so above the water there is a oil is there. So water height, that is hw, and oil height from here to here, this is h0. Now consider this is the width of the plate, that is b, and this is the free surface here. Now if you want to calculate the pressure force due to oil, that is equal to pg1. So this is g1 is the center of gravity for due to oil, and this is the center of gravity. Okay, now if you want to calculate the pressure force due to oil, that is pg1 into area. So here that is pg into area, so that's why area of oil, sorry, f of oil, that is equal to pg1 into area of oil. Okay, area of oil plate. So here pg, that is equal to rho of oil, g into what is the distance, this is h0 divided by 2. So this is h0 the height, h0 by 2 into the area of oil, that is h0 into b. So this is the area of the plate. Okay, so from here we can calculate the pressure force due to oil. Now if you want to calculate the pressure force due to water, that is Pg2, you have to multiply by Pg2 into area of water. So how to calculate Pg2? That is just you have to add this pressure, rho g h, rho 0, rho 0 is the density of oil, g is the gravitational acceleration, h0 is the height of this from here, plus rho of water, g hw, this height divided by 2 into this area of this plate. So hw into b is the width of the plate. So from here you can get the pressure force due to water. Now if you want to calculate the total pressure force, that is equal to f of oil, pressure force due to oil plus pressure force due to water. So this is the concept, you have to remember this concept. Now we'll understand one important question that is very important for gate exam. So let's try to understand this. A hinged gate of length 5 meter inclined at 30 degree with the horizontal and with water mass on its left is shown in figure below. So this figure is given in this question. Density of water is 1000 kg per meter cube. The minimum mass of the gate in kg per unit width perpendicular to the plate of paper required to keep it closed. So what is given in this question? So given that this L here to here, the distance is the L that is equal to 5 meter, which is given in this question, and theta, this angle theta is equal to 30 degree, and density of water that is 1000 kg per meter cube, which is given in this question. And now what is given? The W is also given, that is the width of the plate that is perpendicular to this paper, that is equal to 1, and you have to calculate the mass of this plate. So this is given in this question. So A, B, the length is 5. So the mg, the weight of the plate act in this point. So mg is act in this point. So this will be the mg cos theta component. So this is the mg cos theta component because this is theta 30 degree. So this will be 30 degree. So this will be mg cos theta. Okay, mg cos theta. Now if you want to calculate this distance, so here to here, if you want to calculate this distance, that is 5 divided by 2, that is 2.5. And if you want to calculate here to here distance, that is 2 by 3 into this total height, 5. So 5. So 2 by 3 into 5. So this is the height. This is the length from A to CP. So that is 2 by 3 into 5. Okay. Now if you want to calculate this height, if you want to calculate here to here, we know that is 2.5. But if you want to calculate here to here, we know that sin 30 degree, that is equal to x bar. So this is the, consider this is x bar divided by 2.5. So 2.5, this is the length. Okay, so from here x bar that is equal to 2.5 into sin 30 degree. So there is, so consider if this is 30 degree and if this is 2.5, so this will be 2.5 sin 30 degree. Okay, this is the height of the plate. Now if you want to calculate the pressure force, that is equal to omega A into x bar. This is the standard formula, that is Pg into area, that is the volume of pressure diagram. So that is equal to rho into g, omega that is equal to rho into g, area into x bar. So rho, that is the density 1000 into g is the gravitational acceleration into area. What is the area of this plate? So this is the 5 is the length and width, that is 1. So 5 into 1. And what is this height? Here to here, what is this height? That is 2.5 sin 30 degree. So from here you can get the pressure force that is equal to 6250 into g is the gravitational acceleration, the unit will be Newton. Okay, now if you want to calculate the moment about A, that is equal to 0. So here this is acting clockwise direction, so mg cos theta is clockwise, that's why negative. Mg cos 30 degree into what is this height, that is 2.5. So multiplied into 2.5 plus pressure force that is acting anti-clockwise, that's why positive sign, 26250 g into, and what is this height? So here 2 by 3 into 5. So this is 2 by 3 into 5. So multiplied by 2 by 3 into 5, that is equal to 0. So from here you can get the mass, that is 9623 kg. So this is our answer. So when you calculate the moment, the clockwise that is negative and anti-clockwise that is positive. Okay, so this will be our answer. Now another interesting question. So try to solve this by your own, but I solved this question in this video. So a 280 kg 6 meter wide rectangular gate is hinged at B and leans against the floor at A, making an angle of 45 degree with horizontal. The gate is to be opened from its lower edge by applying a normal force at its center. Determine the minimum force if required to open the water gate. So this is given in this question. So here understand this question. So this is the baseline here. So here to here, there is water is there. So there is water is there, and the density of water, that is, you know that 1000 kg per meter cube. Now here to here the height is 3 meter is given, and here to the free surface, so up till this distance there is 0.5. This is given in this question. Now this B point, that is a hinged point. Now if you want to calculate the force, how to calculate this force at point C? So this is point C and this is point A and this is angle 45 degree. Now if you want to calculate the force, that determine the minimum force, you have to find out the minimum force which is required to open the water gate. So let's try to solve this question, very important question. So what is given in this question? Mass, that is 280 kg, W that is equal to 6 meter, W that is the width, that is equal to 6 meter, and theta that is 45 degree, which is given in this question. So you have to find out the force. So if you want to calculate this x bar, so same diagram here, that is B, A, and this is point C. So here the force is acting in that direction and this direction. This is force, and the mg is the weight of this plate. This is mg and this is theta. So this is theta, so mg cos theta will be this component, and here at point D there is a pressure force which is acting at the center of pressure, we know that. So this is very important question. Try to remember this, try to understand this question, very important question. Okay, so height is 3 meter and here to here that is 0.5. So if you want to calculate the value of x bar, how to calculate that? So this will be 0.5 plus, so if this is 3 meter is given, so here to here the distance is 3 by 2, that is 1.5. So 1.5 plus 0.5, so 1.5 plus 0.5, that is 2 meter. Now if you want to calculate the h bar, we know the formula, IgG sin square theta divided by A x bar plus x bar. from here that is equal to 6 into 3 root 2. What is 3 root 2? AB is the, so this is the, if this is 3 meter and this is 45 degree, so what is the value of AB? That will be 3 root 2. So 6 into 3 root 2 whole cube divided by 12 into sine square 45 degree divided by, so what is the area of this plate? That is 3 root 2 into 6 is the width of the plate into x bar, we calculate that is 2 plus 2. So from here you can get the value of h bar, that is 2.375 meter. Now so h bar, so here to here, so this is the center of pressure. So here to here, this is the distance h bar. So h bar that is equal to, you can write in that way, that is n plus, so consider here to here the distance is n, here to here the distance is n. So if you want to calculate the value of n, you can write in this way, h bar that is equal to n plus 0.5. So n that is equal to 2.375 minus, so this is 2.375 minus 0.5. So from here that is will be 1.875 meter. Now if you want to calculate the value of BD, how to calculate the value of BD? So BD that will be, so if you know this n value, so this is 1.875 and this is 45 degree, so from here you can calculate the BD value, and the BD value will be 2.6516 meter. And AB we know that 3 root 2 meter, and BC that is 3 root 2 by 2 meter. So if you want to calculate the pressure force, we know that omega into A into x bar, omega that is rho into G into area, that is 3 root 2 into 6 and x bar into 2. So from here you can get the pressure force, that will be 499.43 Newton. Now if you want to calculate the moment about B, so here this is B, so this is B. If you want to calculate the moment about B, so this point, so FP, pressure force is acting clockwise direction, so sorry, anti-clockwise, so that's why positive. So FP into BD, this is the perpendicular distance BD, plus mg cos theta, which is acting also anti-clockwise direction, that's why plus mg cos theta into, what is the distance? So mg here to here the distance is BC, and that is equal to, force is acting anti-clockwise, that's why that is equal to F into that is the perpendicular distance B to C. So if you put the value FP, BD and BC value and mg value and BC value, then you will get the pressure force, so pressure force, and the answer will be 626.25 kilonewton. So this is very important question. Just try to understand this question and solve this question by your own. Now there is a note point is that, so if there is a free surface and this is the height of the plate, and this is the center of gravity, this is the center of pressure, and x bar that is equal to h by 2 and h bar that is 2h by 3. Now so here we see that the pressure changes when the depth is increases, but at huge depth the intensity of pressure is uniform. Okay, the uniform pressure after huge depth. So here after some distance the pressure changes along depth, but at huge depth the uniform pressure is there. So as the depth of immersion of a vertical plate surface increases, the location of center of pressure falls closer to the center of gravity of the area, because the pressure diagram uniform.